So let's cut to the chase and look at the first question. Question number 9. The 3 points on this line have been plotted at 0, 0, 3, 1, and 6, 2. So we can write down the 3, 1, 2, 3, and we can also write 4. The question is asking for what are the coordinates of the 9th point. So dot, 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 all the way to 9. So we know the first point is 0, 0. Second one is 3, 1. The third one is 6, 2. So this is the x, y coordinates together. If we are looking at the x coordinate, we see it is 0, 3, and 6. So it has a pattern. So we're adding 3 each time. So that means for the fourth one, we will have 9, 3. So the x coordinate for the fourth one will be 9. And if we write 0, 3, 6, 9 in the form of products, it will be 0 times 3, 1 times 3, 2 times 3, and 3 times 3. So you find a pattern. We find the relationship. And here is 1 and here is 0, 2, 1, 3, 2, 4, 3. Then for the 9th point, we will have 9, 8. So it will be 8 multiplying 3. So the x coordinate instead of 27 for the 9th point will be 24 instead. Okay? Lots of students made a mistake at this for the x coordinates. And the y coordinate is the same story. It's even simpler. So with the y coordinate, we have 0, 1, 2, 3. So 0, 1, 2, 3. And then we say 1, 0, 2, 1, 3, 2, 4, 3. Then for the 9th point, we will have a y coordinate of 8. So we have the x and y coordinate for the 9th point. It will be 24, 8, which is A. So let's move on to the next one. Question number 12. A basketball costs 42.4 pounds. The price is increased by 1/8. So what does that mean? That means we're adding 1/8 of the original price to itself. So we can write the equation 42.4. This is the new price. New price equals to 42.4 plus 42. So 1/8 of 42.4. So times 1/8. So we can either take out the common factor to 42.4, or we can first find the product here and then the sum. So let's use the second method. 42.4 plus 42.4. This is equivalent to divided by 8. So 42.4 divided by 8 will give us a quotient, which is 5.3. And the new sum will be 47.7 pounds. And here is another question. Say if I have a pen in my hand and the pen costs 2.5 pounds in the shop. And if I give the seller 2 pounds, will he give me the pen? Obviously not, right? Because it's less than the amount I should pay. So the lowest amount I need to buy this 2.5 pound pen is 3 pounds. So we have to move up. We have to be more than the amount we need. So this is the same story. Should we use 47 pounds as our correct answer? No, because if we give the seller 47 pounds, we don't get the 47.7 pounds basketball. We have the lowest amount we need to buy it is 48 pounds. That's why C is the correct answer. Yes, and then let's move on to question number 15. Alfred is 3 times as old as his son Barrett. Barrett is 7 years older than his brother Carl. So we have 3 people, Alfred, Barrett, and Carl. So for this is a sum, difference, and multiple type of question. And for these type of questions, we can always solve them using the bar chart method. So to set up the bar chart, we first find the least quantity. So who is the youngest? According to the question, we know Carl is the youngest. So we can represent Carl with 1 bar. And we know Barrett is 7 years older than Carl. So Barrett will be bar plus 7. So these two are equal. And then Alfred is 3 times as old as Barrett. So Alfred, we can represent as 3 times Barrett. 1, 2. This is equal. This is equal. This is equal. This is equal. This is 7 as well. And we are 3 times as old as Barrett. So we will have 2 other 7. So you can consider as we have 2 duplicates of Barrett. right here. And we know the total age of them three is 53 years old. We want to know how old is Alfred. Right, so we know because we have 3 times Barrett, that we will have 3 of these equal bars. So 1 tick, 2 tick, 3 ticks. Altogether, we will have 1, 2, 3, 4, 5. 5 ticks or 5 bars. They're all equal to each other. So we have 5 bars, or I will represent it as ticks. And how many 7 do we have? We have 1, 2, 3, 4. 4 sevens. So equals to 53. Okay, I'll write it in order first. So 5 ticks plus 4 times 7 equals to 53. This is our sum, the sum of the 3 people. So moving this 4 times 7 to the other side of the equation, we will get 5 ticks, so 5 bars equals to 53 minus 28. So 5 ticks equals to 25, and that will give us 1 bar, so 1 tick is 5. So that means Carl is 5 years old, and Barrett is 7 years older, so Barrett is 5 plus 7, so Barrett is 12 years old, and Alfred is 3 times as old as Barrett, so Alfred will be 12 times 3, and Alfred will be 36 years old. So A is the correct answer. Let's move on to question number 21. So question number 21 is about divisibility. Which of the following numbers must be a multiple of 4? So we want to find a number that is divisible by 4. Some digits are covered by ink stains. So here, let's do a little recap about divisibility. First of all, the first type of divisibility is looking at the last n digits, so several digits. For example, the first type is 2 or 5. We're looking at the last digit, so just 1 digit. The second type is 2 squared, which is 4, and 5 squared, 25. And we will be looking at the last 2 digits. And the third type, the last type, is 2 cubed, which is 8, and 5 cubed, which is 125. So that will be, we'll be looking at the last 3 digits. So for example, with 2, we know as long as a number that ends with 0, 2, 4, 8, and 0, sorry, there should be a 6 in the middle. So 0, 2, 4, 6, 8, it will be a multiple of 2. Yeah, so we are looking at the units digit, the last digit. And with 5, it's the same story. As long as a number ends with 0 or 5, it will be a multiple of 5. And for 4, which is this question, we can have a look at A. So we are looking at the last 2 digits, 62. So is 62 divisible by 4? Obviously not. We have a remainder of 2, right? So A is not a correct answer. And then B, we have ink stain 6. So if this is 0, 6 is not divisible by 4. So B is not a correct answer. If the ink stain is 6, it will be divisible. But if it is 2, like 26, 26 is also not divisible by 4. So B is not a correct answer. It might be, but it's not definite. We cross out B because we're looking for the must be. And then for C, if you look at this, we have something 5. So a 2-digit number with units digit of 5. If you look at all the multiples of 4, all the 2-digit multiples of 4, you'll find that none of them ends with 5. So that means C is definitely not a correct answer. And D, I know most of you made a mistake by choosing D, because 4, 4 something 4 looks really, it looks almost certain that it must be a multiple of 4. So 1, 1 something 1, yeah? But after learning the rules of divisibility, you know that we should only look at the last 2 digits, so something 4. If we have 24, yes, it will be a multiple of 4. It is divisible by 4. But if we have 14, is 14 divisible by 4? It is not. We have a remainder of 2. So that means D is not, it must be a multiple of 4. So D is also not what we're looking for. And E, finally, the last 2 digit is 36. 36 is definitely a multiple of 4. 4 times 9 is 36. So E is definitely, it must be a multiple of 4. Oops, sorry. So tick. E is the correct answer. And this is the first type, the last n digits type. And we can look at the second type. The second type is called sum. We're just doing a little recap. The first type is 3 or 9. So we're looking at the sum of every digit. I'm sure most of you know the divisibility rule for 3. For example, if we have 135 and we want to know if it is divisible by 3, we can simply add all the every digit together, and the sum will be 1 plus 3 plus 5, and that will be 9. So 9 is a multiple of 3. Yes, it is divisible by 3, 9. So 135 is divisible by 3. And it's the same story for 9. And then there's a second type. The second type is called 33 and 99. So for this type, we will be looking for the sum of every 2 digits. So for example, let's say a mega number, say 3, 5, 6, 4, 1, 8, 8, 1. So 3, 5, 1, 8, 6, 4, 8, 1. Yeah, and we want to know if it is divisible by 99. So for this, we cut this mega number into four pieces, and each piece is a 2-digit number, and we add them up. So we have 35 plus 64, which is 99. And then we also have 18 plus 81, which is 99 as well. So 99 plus 99 is definitely a multiple of 99. So it is divisible by 99. That's how we do it. The third type is called difference, the difference of several digits. But the most commonly used divisibility rule is these 2. So we will only go through these 2 today. You keep these 5 rules in mind, and it will suffice for 99.9% of all the questions you will encounter in the future. Right, and then let's look at question number 3. Question number 23, which is a date problem. So on 1st of February 2022, Mr. Evans started saving £1 every day. In which month had he saved £100? So we're saving £1 each day, and how many days later will we have £100? We simply use 100 divided by 1, and that will give us 100 days. So that means 100 days later, Mr. Evans will have saved £100. So we know we're starting from 1st of February 2022. So first, because we're dealing with February, see? So we have the first thing we need to do is to decide if 2022 is a common year or a leap year. So first, common or leap. So remember the rules for us to judge if a year is common or leap or not is if it is divisible by 4. Okay. And luckily, we just learned the divisibility rule for 4, which is look at the last 2 digits. So is 22 divisible by 4? Obviously, it's not. It's not divisible by 4. We have a remainder of 2. So that means it is not a leap year. It is a common year. And in common years, how many days do we have for February? 28 days. Yeah. So with this being clear, we can say we have 28 days in February, and it's definitely less than 100. And then we have in March, March always has, remember the knuckle rule you learned in the crash course part 1. We have 31 days in March, and April is a gap, and gaps always have 30 days. So up till here, how many days do we have in total? We have 89 days in total. The rest is 100 minus 89. So we have 11 days left. This is February. This is March. This is April. And the next month is May. So 11 days. So it will definitely be some day in May. So it's May 5th, May 11th. So in which month had he saved £100? It will be May. C is the correct answer. Yes. This is the second step. This is the third. Yes, let's move on. To question number 26, coordinate problems. So 3 identical rectangles are drawn. What are the coordinates of P? So looking at point P, we want to find its coordinates. We find point P is a corner of the rectangle on the right of the y-axis. So basically, the question, we rephrase it. Instead of looking for the coordinates of P, we're just looking for the width of the rectangle and the length of the rectangle. So how do we find the width and the length of the rectangle? I'm sure most of you already know when looking at this question again. So there is a point given to us that is known, which is -9 and 24. The -9, we don't need to bother with the negative or positive, because we only want to know the length, the length of the width right here. So if you look at it down, if the x coordinate of this point is -9, then it means that this point right here is -9. So that means the width, this is 0, this is -9. The width will definitely be 9. Okay, I'll write it here. Width is 9. And if we look at the y coordinate is right here. So it is consisted of a width and a length. So width plus length equals to 24. And we already know that width is 9. So that means a length is 24 minus 9. So it'll be 15. Okay. And the question is asking us to get the width. The width is the x coordinate and the length is the y coordinate. So it'll be 9, 15, which is the correct answer. So D is the correct answer. Right, moving on to the next question, question number 28. So with these graph problems, one thing that is giving most students a hard time is the axes. So what does each axis mean? That's what most students get wrong. So for this one, the x-axis, the horizontal one, it means the number of marks. It's not the number of students, so make sure you get that right. The vertical axis, the y-axis, means the number of children. So for example, with this column right here, it means the number of children who get 0 marks. See, we have 0 here is 2. So we have 2 children getting 0 marks. And the second column, it is halfway between 0 and 2, so it'll be 1. So 1 child got 1 mark. And then this is 4. So 4 children got 2 marks. Okay, and then let's look at the question. The question is looking for how many children got fewer than 7 marks. So first we look at the horizontal axis, which is here. So fewer than 7 marks, we will look at all the columns before the 7 marks. So all the columns on the left. So I have already marked 2, 1, 4, and this is halfway between 6 and 8. This is 7. So this is a good habit. You can mark all the numbers. What does each column represent on top of it? Yeah. And then the fourth. So how many children got 4 marks? 10. How many children got 5 marks? 8. How many children got 6 marks? It's halfway between 14 and 12. So it's 13. So we add them all together. We have 2 plus 1 plus 4 plus 7 plus 10 plus 8 plus 13. So we only have addition here, so we can add the numbers the way we want it in arbitrary order. So we can do 2 plus 8 first. 2 plus 8 is 10. 10 is 10. And then 13 plus 7 is 20. And then 1 plus 4 is 5. So the rest is easy to calculate. This is 45. So 45 children got fewer than 7 marks. C is the correct answer. Moving on to question number 29. Lily left home at 4:15 p.m. to go to the cinema and arrived at the cinema at 4:35 p.m. So that means for Lily to go from home to the cinema, we can get the answer through observation. It takes her 20 minutes. So 20 minutes from home to cinema. This is the first thing. And then an hour and a half later, she finished watching the movie and went home. So most of the students got 6:05 as the answer, which is wrong because Lily cannot teleport like Doctor Strange, like teleport back home using a sling ring, right? She cannot. She has to walk home. So she will need at least 20 minutes to walk from cinema to home. Yeah. So let's have a look. So the movie starts at 4:35 p.m. And the movie after an hour and a half, it ends. So it ends at 4:35 plus 1 hour and 30 minutes. So this is a column addition. Remember your crash course part 1, we've learned about this. This is 35 plus 30 and it's 65. We cannot have 65 minutes in an hour, so we can only write 0.5, yeah, and then carry a 1 to the hour. So 4 plus 1 plus 1, it will be 6. So it's 6:05 p.m. The movie ends at 6:05 p.m. and Lily comes out from the cinema and starts walking home. She needs 20 minutes. So 6:05 plus 20 minutes and that will be the time she gets home, which is 6:25 p.m. So E is the correct answer, not C. This is a typical wrong answer. Right. Let's move on to question number 30, which is an efficiency problem. It takes a worker 10 days to build a wall, so one wall, if he works 8 hours a day. So altogether, so if we're working 8 hours a day and 10 days in total, it will be 8 times 10, 80 hours. So one wall will take one worker 80 hours to build. And let's look at the question. If each worker only works 4 hours a day, how many workers do you need to build 6 such walls in 10 days? So we're building 6 walls. And this is 80 hours for one wall. If we're building 6 walls, we have multiplied the 6. Then we have to multiply with the hours we need as well. So times 6, which is 480 hours. So to build 6 walls, we need a total workload of 480 hours. Okay, and we want to finish this work in 10 days. So 480 divided by 10 will give us how many hours we need to work in each day, in one day. So 48 hours. We need to work 48 hours a day. Yeah. And we also know from this sentence, if each worker only works 4 hours a day. So each worker only works 4 hours. So how many workers do we need? It's divided by 4. And that will give us 48 divided by 4, 12 workers. We need 12 workers to build 6 walls in 10 days. So the correct answer is D. Right. This question is pretty hard. Let's look at it. So you see it has a very low correct rate. So the number directly above 1 is 13. And we want to know what is the number directly above 43. So the number here, the number represented by the question mark. But because we're looking at, you see, these all look like triangles, and we're looking at the corner, the vertices of the triangles, the 1, the 3, the 7, and the 13, the 21, the 31, the 43, 57, and then there is another vertex here at the bottom right corner, and then another one at the top. So this one is what we're looking for, the number directly above 43. So if we look at these vertices, we write down the numbers horizontally. That will be easier, more straightforward for us to see. We will have 1, 3, 7, 13, 21, 31, 43, 57, and then a circle, and then the question mark. So we want to find the question mark. Yeah. So let's observe the sequence we have here. For those who have been with us, both the short-term course and the crash course part 1, this one will look familiar with you because this is a quadratic arithmetic progression. What does it mean? Let's have a look. So the difference between 1, 3 is 2. Difference between 3, 7 is 4. Difference between 7, 13 is 6. And then 8, 10, 12, 14. So you see the difference between each term. They are an arithmetic progression. Okay, so that's what quadratic arithmetic progression means. So the sequence itself, the difference is an arithmetic progression. So this one, so from 57 to the circle, we know the difference between 43 and 57 is 14. Then the difference here should be 16. We can predict. And then 57 plus 16 will give us the circle right here, which is 73. And then from 73 to the question mark, what number should we add? We see 2, 4, 6, 8, 10, 12, 14, 16. Then this difference here should be 18. Very good. So to get the question mark, we simply use 73 plus 18. And that will give us 91, which is the number directly above 43. So which choice is 91? B. B is the correct answer. Right, and then let's move on to question number 34. Scott spent 24% of his savings on the car. The car is worth 72,000 pounds. How much money does he have now? Right, so we know this is a whole and part problem. So we know the cars is 24% of his whole savings. Okay. Then correspondingly, this one will be 76%. This is what's left. and the number, the remain is what we're looking for in this question, because we want to know how much money does he still have right now. So we know the car is worth 72,000 pounds. So that means this part is 72,000 pounds. So for the whole and part type of question, yeah, there are two situations. The first situation is we know the whole and we want to find the part. So we know the part is a fraction of the whole. Okay, say there's a fraction, say A over B, and then we know the whole is say 1,000. So to find the part, we use multiplication. We take the whole and we multiply the fraction. Yeah. And the second type is we don't know the whole. We want to find the whole, but we know the parts. And we also know the fraction of part over whole. To say this is also A over B. We know the part. Say the part is 1,000. And then to find the whole, from part to whole, we use division. So 1,000 divided by A over B will give us the whole. Okay. So this type of question is definitely the second situation. So we know the part, we want to find the whole. So this is 24%, which is 24 over 100. And we also know the exact amount, the number is 72,000. So you can do 72,000 divided by 24 over 100. So that gives us the whole right here. And the answer should be, so it's 72,000 times 24. Remember, dividing a fraction is turn the fraction on its head and multiply instead. So times 100 over 24. 24 is a factor of 72 because 72 is 24 times 3. So it cancels out, leaving a 3,000 times 100. So it's 300,000 pounds. The total is 300,000 pounds. I think I've written one more zero. Yes. So altogether, Scott has 300,000 pounds. He is rich. And we want to find how much money does he have now. So you can either subtract 72,000 from the 300,000, or you can take 300,000 times 76%. Either way, you will get the correct answer, which is 228,000 pounds. C is the correct answer. Right, let's move on. 35. Thomas and Fred are good friends. One day, Thomas drove from his house to Fred's house without stopping anywhere on the way. This is important. Without stopping anywhere on the way. And then after arriving at Fred's house, they took a rest. These two are very important, key information. And then they went to the gym to play tennis. The graph shows Thomas's journey. So we have a graph. This is a distance time graph. Some students are struggling with the distance time graph. They don't know what it means. So for distance time graph, the vertical axis, the x-axis means the time. So this is at 0 minutes, and this is at 20 minutes, this is at 40 minutes, this is at 60 minutes. Yeah, so the time is moving. And then the vertical axis is the distance from Thomas's house. So here at the origin, we have 0, 0. That means we just start. We're starting to move from Thomas's house. And then at this point, we have 20. So we're 20 kilometers away from from Thomas's house. And here we are 40 kilometers away. And here we're 60 kilometers away from Thomas's house. And on this distance time diagram, a horizontal line, so a line that's flat, it means that our time is moving. So say this is from 40 minutes to 60 minutes, say this red line I drew over here, from 40 minutes to 60 minutes, our distance didn't change. It is always 30 kilometers. So that means we are staying still. That means we're having a rest. Yeah. And when the line is moving from lower to higher, like this, so say from 0 minutes to 20 minutes, we have moved. This is 30, and then 32, 34, 36. So we have moved from 0 kilometers to 36 kilometers away from Thomas's home. So that means we have moved 36 kilometers in 20 minutes. You can find the speed, but that's not necessary in this question. Right, so with that being said, so we're moving away from Thomas's house. And the one moving from higher to lower, that means At this point, we are 56. We are 56 kilometers away from Thomas's house, and at this point, we are 40 kilometers away. So from 60 minutes to 100 from 80 minutes to 100 minutes, we have moved 16 kilometers backward. Yeah, so 16 kilometers closer to Thomas's house. So with these being said, if we're clear with what this diagram tells us, we can look at this diagram. So we know Thomas drove from his house to Fred's house without stopping anywhere on the way. So we will look at the lines, and we look at the first time we have a flat line. That was when Thomas first arrives at Fred's house. So here from 0 to 20, we don't have a horizontal line. This line is not horizontal. And then from 20 to 60, this line is also not horizontal. Some students made a mistake here. They consider from 0 to 20, at this point here, we have arrived at Fred's house. And then from 20 to 60, here we're going to the gym to play tennis. And then playing tennis, and then going back home. That's not the case, because we're not stopping after we arrived at Fred's house. So this is moving, this is moving. So this is the point where we arrive at Fred's house. And then flats, see, we have a flat line, which corresponds to this sentence here. They took a rest, they're not moving, they're staying still. And then they went to the gym, which is 16 kilometers backwards. They went to the gym to play tennis. So when they're playing tennis, they're staying at the gym. They're not moving. They're staying still, right? So that corresponds with this flat line over here. That the whole graph makes sense. So the graph shows Thomas's journey. What is the question? The question is, what is the distance between their houses? So from Thomas's house to Fred's house, okay? Thomas drove from his house to Fred's house without stopping. So from 0 to this point, we only need to look at the difference between the y coordinate, which is 56, and 0. So the distance is 56 kilometers. D is the correct answer. Okay, so the only two key points about this question is, first, know how to read a distance time diagram, and second, know what a flat line, what a sloped line mean on these diagrams. Only two key points. Okay, we have a drink. And then let's move on to the Sudoku one. So the Sudoku one also has a relatively low correct rate, only 35.29%. Looking at the grid in which there are some empty squares. And we know when every square is filled in, each row and each column adds up to 56. So we want to know what number should be in the square with the question mark. We want to find this one. And we know that the bottom row, they should add up to 56, right? So that means the question mark plus this blank plus 18 should be 56. And do we know how to find this? The way we find this is to look at the middle column, right? So this tick plus the 40 plus this circle right here will also give us 56. And can we find the circle? We can, yeah, because at the top row, 12 plus circle plus 21 is 56. So circle is 56. 56 minus these two added up is 33. So move 33 to the other side. So minus 33, and the circle will be 23. So the circle here is 23. And then to find the tick, most students made a mistake here because they haven't think of the possibility of adding, because we see 23 plus 40 is 63. 63 is larger than 56. How can we add a number and become large and become smaller? So here is the possibility. We can add a negative number. Yeah, so from 63 to 56, we need to minus 7. So 63 minus 7 is 56. But minus 7 can also be written as add a negative number. 63 add minus 7. Add negative 7, and that is also 56. So that means the tick should be minus 7. Yeah, so question mark minus 7 plus 18 will be 56. So 56 minus 18 plus 7 will give us the question mark, which is, this is 38. 38 plus 8 is 45. So 45 is the final answer. Just remember, in these type of questions, if it is not specified in the question, you can consider negative numbers. Okay, the answer is E, 45. Right, and then a geometry question. This is my favorite actually, because it is very elegant and beautiful. So a square is formed using 8 identical big rectangles and 2 identical small rectangles. What fraction of the area is shaded? So we have 2 big rectangles and 1 small rectangle shaded. Right, then let's have a look. So there are 3 hidden conditions given in this diagram. It's not given in the form of words from the question, but it's given in the diagram. So that's why I love it, because lots of things is unspoken, but it's given. So the first one is here. So you see, the width of the small rectangle equals to the width of the large rectangle. So small width of small, I'll use S to represent. S equals to big, so B width. This is the first. And the second one is here. Sorry. You see? So for the length of a big rectangle, it is equal to 4 widths. Okay. So because we know the small width and the big width is equal, so we can just use widths to represent. So let's say we represent them with a letter, representing unknown with letters, yeah, with A. So the width is A. Then the length, the big length, will be 4 times A. So it's 4A. And then the third hidden condition is here. So the small length, the length of the small rectangle is 2A. Okay. With that known, we can calculate the area of the shaded area. Okay, so it's 2 big rectangles. For a big rectangle, we find the area, remember, using width times length. So width times length, that will be 4A times A, which is 4A squared. Don't be afraid of the A squared right here. They will be canceled out. And then for the small rectangle, we want to find this area. We can use length times width, and that will be A times 2A. So 2A times A will be 2A squared. And because we have 2 big rectangles, we need to times 2 to the 4A squared. So 4A squared times 2 will be 8A squared. So altogether, the shaded area, we have 8A squared plus 2A squared, which is 10A squared. This is the shaded area. So I'll use A, capital letter A to represent area. So A shade equals to 10A squared. And here, this is the length of a small rectangle. This is the length of a large rectangle, of a big rectangle. So it's 4A and 2A, respectively. So because we know it's a square, so the side length of a square is 2A plus 4A, and it will be 6A. So the side length is 6A. And everyone remember how we find the area of a square? It will be 6A times 6A, which is the total area. So it's 36A squared. So the fraction, we want to find the fraction. So it's A shade over the whole. So it will be 10A squared divided by over 36A squared. Remember, I said A squared can be canceled out. It's both in the numerator and the denominator, so can cancel them out. What's left is just 10 over 36. So 10 over 36, leave the fraction in simplest form. And we see there's a common factor 2. So cancel 2 on both top and bottom. We will have 8 over 15. So 8 over 15 is the final correct answer. So D is the correct answer. Very elegant, this question. Let's move on to question number 40. If 14th of July is a Monday, what day of the week will 28th of August be? So for this type of question, this is a cycle. This is a cycle problem that involves date. So a week is a cycle, it's 7 days. But remember, we have to figure out which day are we starting from. So if we know 14th of July is a Monday, then the cycle will actually start from Tuesday, because the following day, because we're starting to count at 15th of July, which is a Tuesday. So we're starting from Tuesday. So the cycle starts from Tuesday. So it's Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. It's like this, instead of starting from Monday and ending at Sunday. So for these type of date problems, I strongly recommend we first write down the cycle we have, the new cycle, which is Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then Monday. This is our new cycle, okay? And then we find how many days do we have in total. The second step is 14th of July. How many days do we have left in July? So there are 31 days in total in July. Then we will have 31 minus 14, and that will be 17 days. We have 17 days left in July, and till 28th of August, we have 28 days. So 17 plus 28, we have in total 45 days. And 45 divided by 7, we have 7 days in one cycle. We want to find out how many cycles do we have. It will be 6 with a remainder of 3. So 6 times 7 is 42 with a remainder of 3. So we don't care about the cycles. We don't care about how many weeks have passed. We want to know what day of the week will 28th of August be. So we only look at the remainder right here. The remainder is 3. So we go back to the cycle right here, and we count the third term of our new cycle. So 1, 2, 3. Thursday is the third term, so the correct answer is Thursday, D. Okay, so this is how we solve these type of cycle problems with date. Right, let's move on to fraction calculations. 41. 6 apples weigh 2 and 5/2 kilograms. Henry buys 4 bags of such apples, each containing 15 apples. What is the total weight of these apples? So one way, the first method to do this is we do it in order. So 6 apples, we know 6 apples weigh 2 and 2/5. So we convert this into improper fraction. So 2 times 5 plus 2 divided by 5, which is 12/5 kilograms. And that's 6 apples. So 6 apples. And to find each apple, the weight of one apple, we divide by 6. And then we divide 12/5 by 6 as well. So I hope you're happy with your fraction divided by a whole number, which should give us 2/5 kilograms for one apple. Okay, and then we find out how many apples do we have. So we have 4 bags, each bag's containing 15 apples. So we have 2/5. This is the weight of one apple, and then times 4 times 15. This is the total number of apples we have. And that will be 2/5 times 60, which is, this is 5 times 12 is 60. So we can cancel out the 5, leaving a 12. So it's 24 kilograms. The weight of these apples, the total weight of these apples is 24 kilograms, B. And then there is also another, a faster way. So for those who are number sensitive, yeah, you look at the 4 and you look at the 15. You think, they look familiar, and they look, somehow my instinct tells me they can make my life easier if I do them first. So 4 bags of apples, each containing 15 apples. So 4 times 15, we have a total of, we find it 60 apples. And we know 6 apples weigh 12/5 kilograms for 6 apples. Then for 60 apples, we simply time 10 to the 12/5. And that will be 5 and 10 cancels out, leaving a 2. So it's also 12 times 2. Well, this calculation is much more easier. So correct answer is still B. And then let's move on to question number 42. The spinner is divided into 10 identical parts. So this is the spinner here. We know there are 10 equal parts. If we turn the spinner and observe the number that the pointer stops at, what is the probability that the number is prime? So we're dealing with prime numbers in this question. So lots of you made a mistake. So there are two traps. The first trap is you think all the odd numbers are prime numbers. Say we have 1, 3, 5, 7, 9 below 10 when we're considering below 10, so just one digit. So you're considering them all as prime numbers. But the case is 1 a prime number, 1 is not. The definition of a prime number is it only has 2 factors, 1 and itself. And how many factors does 1 have? Only 1. It only has itself as a factor. Okay, so 1 is not a prime number. And then 9, is 9 a prime number? It is not. It is a square number. 3 times 3 is 9. So 9 is also not a prime number. So for odd numbers, we only have 3, 5, 7 as one-digit primes. And then for odd numbers, yeah, some of you have forgotten that 2 is a prime number because it only has 2 factors, 1 and itself. See? So this is odd and this is even. So 2 is also a prime number. The others are not. The others are all multiples of 4, multiples of 2. So they all have a factor 2. So 2, 3, 5, 7. We have 4 prime numbers that are less than 10. And then let's look at this spinner. We have 2 and then 4, not a prime number. 6, no. 8, no. 7, yes. 5, yes. 9, no. 3, yes. 1, no. 5, yes. So how many prime numbers do we have? In total, we have 1, 2, 3, 4, 5. So we have 5 prime numbers. So 5 prime. And then we have 10 identical parts in total. So divided by 10 will give us the probability that the number is prime. So the probability, remember your equation, the number of, so we'll use hashtag. The hashtag means number. So number of occurrences divided by number of total conditions, total situations, or total possibilities. And that will give us the probability. And in this question, we have 5 over 10, which is 1 over 2. So D is the correct answer. Let's move on to question number 45. So what is the largest number of cubes of side 0.5 centimeters that will fit into the cuboid below? So there are 2 methods, again, for this question. Both are correct. Both will give you the correct answer. The first one is we can find the total area, the total volume of this cuboid, which is 5 times 3. So length times height, length times width times height. So 5 times 3 times 2. And that will be 30 centimeter cubed. And then we find the volume of 1 little cube, which is 0.5 times 0.5 times 0.5. So we have altogether 1, 2, 3 digits behind after the decimal point. So we should also have for the product 3 digits behind the decimal point. So 5 times 5 times 5 is 125. So it'll be 0.125 centimeters cubed. This is the volume of 1 cube. And then we have the total, we have 1. We want to find out how many cubes can we fit into it. So we have 30 divided by 0.125. And that will be divided by 0. So if you remember your decimal and fraction conversion, 0.125 is 1 over 8. So it's 30 divided by 1 over 8 divided by a fraction is turn the fraction on its head and multiply instead. So we will have 30 times 8 over 1. So it's basically just 30 times 8. So it will give us 240 cubes that can fit into the cuboid. But, here comes the but. This first method, it can only work perfectly when we have perfect fit. Yeah, that means we can fit just the right amount, just 240 cubes inside it, and there is no extra space. Yeah, then that way the first method will be good. Yeah, but if say this is not 2 centimeters but 1.6 centimeters instead, okay, then it won't be a perfect fit, and then we cannot use the first method. We should use the second method, which is what I strongly recommend, my favorite method. So we can first have a look. So if we fit this cuboid in layers, in the form of layers, we will first have a layer at the bottom. Let me draw it briefly. Yeah. So the length of the rectangle at the bottom side is 5 centimeters. And to fit into 5 centimeters, we have 0.5 centimeters side length cubes. So how many cubes can we fit into each row? We will have 5 divided by 0.5, and that will be 10. So we can fit in each row 10 cubes. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And then for each column, looking at vertically, for each column, we will have 3 divided by 0.5, and that is 6. So it's 1, 2, 3, 4, 5, 6. Right, and then let me connect the lines. So it's something like this. So for the base, we can fit exactly. If you look at it from top to bottom, you will have 10 times 6. So we have altogether 60 cubes we can fit in the first layer of this cuboid. Okay. And the last, we look at the height, which I have changed into 1.6 centimeters. Okay. So for 1.6 divided by 0.5, we will get 3.2. So we can't fit 3 cubes. So that means we will have 3 layers, but we cannot fit 0.2 cubes into the cuboid. Yeah, so that means we have to narrow it down, round it down to 3. See, this is why we cannot use this anymore. It will give us a decimal number, and the decimal number is not what we want. So using the second method, we can just first look at the length, next look at the width, and then look at the height. So 5 divided by 0.4 times 3 divided by 0.5, sorry, times 2 divided by 0.5. You see, it's basically the same thing. If we multiply the 3 fractions together, it actually gives us the same thing here. So it's 5 times 3 times 2 divided by 0.5 cubed. Okay, so it's same thing, but the thinking process is different. Okay, and the second method is much more convenient when we have the not perfect fit situation. So it'll be, this one is 10 times 6 times 4, and it is also 240. Also gives us the correct answer. So we can fit 240, the largest number of cubes, into the cuboid below. So A is the correct answer. Right, I'll give you 10 seconds to have a think about it, and then we'll move on. And then the 46th question. The 46th question, surprisingly, has a relatively low correct rate of 61%. What number is halfway between 3.5 and 6.9? So we can either draw a number line. So this is 3.5 and 6.9. We want to find the number in halfway, or we can draw two columns. This one is 3.5, and another one is, oops, sorry for my poor drawing. This one is 6.9, and we want to find the one in the middle. So the method is basically just add the two numbers and divide them by 2. So finding the average, finding the number in the middle, and has an equal value or equal distance to both of these numbers. So 3.5 plus 6.9. I wonder, for those who got wrong answers, maybe you did wrong, you miscalculated. But overall, the thinking is very easy. Just plug them into the equation, and that will give us 10.4 divided by 2, and that will be 5.2. So 5.2 is the answer. And let's move on to next question, fraction. So Julie has a bag of flour weighing 1.35 kilograms. She uses some flour to make cakes. Each cake needs 45 grams of flour. See, we're doing kilograms and grams. We're doing different units. So remember to convert your units first. So we know 1 kilogram equals to 1,000 grams. So to convert 1.35 kilograms to grams, we simply time 1,000. So it'll be 1,350 grams. And then the weight of the remaining flour is 2/5 of the original. So you see, this is the first situation I mentioned before, the whole and part. So we know the whole, we want to find the part. Let's draw a line here, and this is 2/5, which is the remainder, which is the flour remained. And this is the flour used, which is 3/5. And we know the whole, the total is 1,350 grams. So to find the used, we simply use the whole multiply the fraction of the used. So it's 1,350 times 3/5. That will give us the exact number of how many grams of flour we have used, which is, So 1350 is a multiple of 5. It is actually 270 times 5. So cancel out, leaving it 270 times 3. That will be 810 grams. And 810 grams is the number of the grams of the weight of flour we used. And we know each cake needs 45 grams of flour. So 810, we simply divide by 45, and that will give us the final answer. How many cakes does she make? Did she make, actually? So it should be 18. 18 is the correct answer. You can do it in the form of 900 minus 90 divided by 45, which is faster and easier to calculate. 900 divided by 45 is 20, and then 90 divided by 45 is 2. So 20 minus 2, 18. And then let's move on. We're almost there. We have 50 questions in total. We have 3 more questions. Everyone, hold on. Stay with me. The figure below shows a picture, shaded part, surrounded by a 5 centimeter border. So this is a border type of problem. So the most common mistake is when you find the new length and the new width and the new length, you only take away 1/5 from the original. But instead, you see, we have 1/5 here, but we also have 1/5 at the bottom. And for the length, it's the same thing. We have 1/5 on the left, but we also have 1/5 on the right. So we have to take away 2 5s. We're looking for the new width and the length. So 35 minus 5 times 2 will give us the new length, and 20 minus 5 times 2 will give us the new width. This is 25 centimeters. Remember, units are very important. This is 10 centimeters, and the area of the picture is 25 times 10, which is 250 centimeters squared, which is A, the correct answer. And 49, Debbie works for a multinational company. She spends an average of 8 days a month abroad on business. So 8 days a month. How many months do we have in a year? We have 12 months in a year. So that means how many days will she be abroad on business every year? It will be 8 times 12, which is 96 days. So on business abroad. And she also spends 10 days a year on holiday abroad. So 10 days on holiday abroad. So altogether, we will have 96 plus 10, 106 days abroad per year. And the question is asking for which is closest to the percentage of time she spends abroad the whole year. So how many days do we have in the whole year? We have 365 days. So we want to find, we have this fraction 105 over 365, and we want to convert this fraction into a percentage. I hope you're happy with your percentage fraction conversion. Now, how do we convert this fraction into a percentage? Yeah, we simply do long division. So we have 106 divided by 365. We first convert it into a decimal number. So 106, we do long division divided by 365. And there is no 365 in 106. So we write 0 point first and then add a 0. So we have 1060 divided by 365. We can write, so it's definitely more than 365 in this number. We can do 2. Can we do 3? So if we have 3, we will have, this is 5, this is 9, so 1095, which is larger than 106, sorry, just larger than 1060. So we cannot have 3, we can only have 2. So with 2, we will have 730. And then 1060 minus 730 is, this is 0, so it's 330. And you see, there is no 330, so we add a 0. Sorry, there is no 365 in 330, so we add a 0. And you see, 3,300 is really close to 10 times 365, which is 3,650. So it's really close, but it's less than. So instead of 10, we can try 9. The next biggest number we can use. So 365 times 9. Let's see what it equals to. 5 times 9 is 5, 45. Write 5, carry a 4. 6 times 9 is 54. Write an 8, carry a 5. 3 times 9 is 27. So it's 32. So 3, 2, 8, 5. We will have 15 left. Right, so brilliant. It is just a little bit smaller than 3,300. So we can use 9. 9 is the correct number right here. We have 15 and then add a 0. But we see 15 is still less than 365. So we add another. So we have to write a 0 here and then add another 0. So up to this point, we don't need to calculate any further, because to convert a decimal number to a fraction, to a percentage, we only need to move the decimal point 2 digits to the right. Okay, so we have 29.0 something %. And which of these choices is closest to the percentage we got? Yeah, so from 29% to 20%, a 9% difference. This is a 4% difference. This is a 1% difference, 6% difference, and 11% difference. So you see, C is the closest. The correct answer is C, 30%. Right, finally, the last question, the 50th one. The area of a rectangle is 48 centimeters. What would be the perimeter? Sorry, the area of a rectangle is 48 centimeters squared. What could be the perimeter of the rectangle? So for this type of question, for a rectangle, we know its length times its width, right? We only need to find two factors. We only need to split 48 into two factors. And for this type of questions, lots of you make repetition mistakes or missing a pair of factors. That is because you're not doing it in order or systematically. That is the word. So we always start from the lowest number, which is 1. And we do it in ascending order. We do it systematically. That way we won't miss any number. So the width and the length. So first we start with 1. So 1 times what number is 48? So it's 48. And then 2 times 24. And then 3. 3 is a factor of 48. And the other number is 16. And then 4, 12. Can we do 5? Is 48 a multiple of 5? It is not. And how about 6? 6 times 8 is 48. How about 7? 7 times, no. 48 is not a multiple of 7, so definitely not 7. And then when we move on to 8, you see here? So 8 and 6. So it's basically the same thing with what we get here. So starting from 8, 6, if we go further, we will just be swapping all the numbers we have here. So it's basically the same thing. We don't need to bother. And plus the length cannot be longer than the width, so we don't consider them anymore. So these 1, 2, 3, 4, 5, these 5 pairs, length and width we got is the final choice, the choice we can have. And then we look at the perimeter. The choices are perimeters. So remember your perimeter equation, which is width plus length times 2 is the perimeter. I use capital letter P to represent. So that means if we divide all the choices by 2, that will give us the sum of the width and length. Okay, we write the sum of the width and length here first. So 1 plus 48 is 49. 2 plus 24 is 26. 3 plus 16 is 19. 4 plus 12 is 16. And then 6 plus 8 is 14. So we divide all the choices by 2. 49 divided by 2 is not a whole number, so A is definitely not a correct answer. 32 divided by 2 is 16. 26 divided by 2 is 13, and this is 12, this is 7. Okay, so we compare the 16 with all these sum we have and see if we have it. Do we have 16? So B is correct. Do we have 13? We don't have 13. Do we have 12? We don't have 12. Do we have 7? We don't have 7. So roll out all the wrong answers. B is the correct answer. Right. That has been a long walkthrough. So this is all we have today for the walkthrough. Thank you for coming. Do you have any question? If you don't have any other question, you're free to go. If you have question, you can raise hand and ask me right now.
For the question that says which one is the middle number?
Yeah, this one.
Is there another way? Because I usually minus them.
Yeah.
And then I divide the number and then add it to 3.5?
Yes, that is a correct alternative way, but this way we're introducing the 3.5. Add them up and divide it by 2 is foremost the most convenient one and the fastest method. What you did is definitely okay as well. So what you did is first you find the distance between 3.5 and 6.9 on the number line, which is 3.4. So 3.4 is this distance, and then you divide it by 2 because we want to have equal distance to 3.5 and 6.9. So that'll be 3.4 divided by 2, so it's 1.7 each. So this number divided by this number is 3.5 plus 1.7 or 6.9 minus 1.7. That's definitely correct. Absolutely no problem. But this one, because in the GL exam, you need time. Time is a luxury. So this one is the fastest method. So we recommend you use this method.